It's the page after we ended on, like the last page we ended on. Which one? Yeah. Okay, so this is the first type that we're going to solve. So what we've done so far is we did solving when we couldn't do common base, right? And if it had one exponent, this was exponential. If you had one exponent, you could change it to a log. But if you had two exponents, you have to log both sides and then work from there, right? That was if it was exponential. Well, these ones are log solving. So when we solve a log, it's different. Now the catch is, if we don't know the value beside the log or in the base, we're going to have to do exponential at some point, right? In order to solve it, we don't know if the variable's in the base or the variable's beside the log. We're going to have to convert it to exponential. That's always going to have to happen, right? That's how we solve those. So this one has an x beside the log. Now, the catch also is that you can't have a negative beside the log and you can't have a negative in the base. So remember when we did rationals and radicals and quadratics and stuff like that last year? Well, it would be mainly radicals and rationals where there was restrictions on the variable. That's a restriction on these variables. Okay, so you always have to check your answer and make sure that when you plug your answer back in, you don't get a negative beside the log or a negative in the base. If you do, it's an extraneous root. It doesn't count. You can't use it. Okay, so we also have to check for that, because what they'll do is they'll list that as one of your multiple choice answers, and you'll pick it if you forget to check. Okay? All right. So we can't do the 7 rule or convert it to exponential at this point, can we? No, because we need to have one log, we need to have a 1 in front of that log, and that's it, and then we can convert. Okay? So what could we do to get one log? Put them together. How can we put them together? Multiplying the x and the 3. So we could use product rule. When you have the same base and you have a log with a 1 in front, you can put them together, right? So we're going to combine logs. So we have log base 9, so we can put them together, and then 3x equals 1. And now what can I do? Now I can convert it to exponential. Could I check this y1, y2? Absolutely. I have one variable in an equation. I can always check those with y1, y2. Now we convert it. So base of the log becomes the base of your exponent. What's with it doesn't stay with it, so the 1 can be with it, and then it's going to equal 3x. And then we're going to divide by 3. X equals 3. Now you can check it back to see if it works, but you can also check here to see if it fits. So you'd have log base 9 of 3. Does that work? Yeah. What if it was negative 3? Would it work? No, because you'd have a negative beside and it'd be extraneous. You can also check these by filling them back in. Log base 9 of 3 plus log base 9 of 3 would be log base 9 of 9, which is 1, and 1 would equal 1. So it would work if you checked it. Okay, so we're good. So that's your easiest one. This one setup's the same, but now we're going to end up with a quadratic. Yeah.
So I have a question. Why wouldn't you just solve for log 9?
Why wouldn't you just solve for it? Because you get a decimal. That's the only reason why. And then you'd have a decimal, and then you could do it. That'd be fine. This way you can't, but that one you could have. Yeah. So here you have log base 5 of x plus 1 and log base 5 of x minus 3. Because you have log base 5, that screams to put them together, right? So you have log base 5, and because they both have positive 1s in front, the two values stay in the numerator. Expand it out. You're going to have to write small because this one's going to be big. Log base 5 of x squared minus 3x plus 1x is minus 2x. 1 times negative 3 is negative 3 equals 1. And now what can we do? Change it to exponential, because if we have x's beside or x in the base, that's what we're going to do. Change it to exponential, right? Ultimately in the end. Now remember, if there is no base, put the base 10 so you remember to raise it 10 to the power of, because people get stuck if they don't put the base there. So you're going to go 5 to the 1 equals x squared minus 2x minus 3. Now I have a quadratic on the right side. What do I have to do whenever I have a quadratic? Equal to 0. So I'm going to get 0 equals x squared minus 2x minus 8. And now what can I do? factor, and if I can't factor, I'm going to have to use decomp or quadratic formula. Yeah. So in this case, I can use product sum because there's a 1. If it didn't have a 1, you use decomp. If it doesn't factor, you'd have to use quadratic formula. If it asked you to do it algebraically, right? You couldn't punch into your calculator. The moment you punch into your calculator, that's graphically. Okay. So we have 0 equals x squared minus 2x minus 8. So what multiplies can be negative 8 and adds can be negative 2. X minus 4, x plus 2. And then we'd have x equals 4 and x equals negative 2. Now, just because it's negative doesn't always mean it's out. If you fill it back in and you get a positive beside, then you'd be fine. So say this was like x plus 3, let's say, and I put the negative 2 in. Negative 2 plus 3 would be 1. So it would actually be okay, right? But it's not that. It's a negative 2. Negative 2 plus 1 is negative 1. Can I have a negative beside? No. Negative 2 minus 3 is negative 5. If it doesn't work for 1, it's out. So this is extraneous. Now I've checked the 4. Sometimes it's positive and it doesn't work too, because it might make a negative still beside, right? So you always have to check them back. 4 plus 1 is 5, so it works for that one. 4 minus 3 is 1, so it works for that one. Seems good. Okay? This one's harder because people don't spot it as easily, because they're all base 10. And when it's base 10, people don't see that they're the same base and don't try and put them together often. Now you could just solve this one out for log 15 and deal with decimals, but that would be a bit harder. So these are both base 10, and so is this one. So you can either keep them on one side and on the other, which is what I'm going to do, or you can move them all to one side, get it equal to 0, and then it would be 10 to the 0 equals 1. I'll show you both ways. So on this way, I'll do the way we just did. So move everything to one side. So log base 10 x minus log base 10 of 15 minus log base 10 of 0.2 equals 0. So now we'd have log base 10, x on the top, and then on the bottom we'd have 15 times 0.2. What's that? Pardon? 15 times 4.5? 15 times 0.2? Is it 4.5? Which is it? 3. Okay. Oh, because it'd be 15 times a fifth. 0.2 is a fifth. So 15 times a fifth is 3, is a third. Yeah. Or 3. So you get the 3. And then you get equals 0, and then we convert it. So 10 to the 0 equals this, which a whole bunch of people tell me is 0. It's not 0, right? 10 to the 0 is actually what? 1. 10 to the 0, x over 3, 1 equals x over 3, multiplied by 3, x equals 3. Okay? So that's how we had to do the other ones. We had to do the other ones this way because it was logs and a number. If you go back, look at the previous ones. They're not all 3 logs, are they? The previous ones are log number, right? Or log number, right? This one is log. So you can do it a second way because they're all logs. So what you can do is put this side together. So you'd get log base 10 of x over 15 equals log base 10, 15, log base 10 of 0.2. Do we agree? Now, if this is log base 10 of x over 15 and it equals log base 10 of 0.2, what could we say? X over 15 must equal 0.2 in order for this to be true, right? We can only do this because every single term is what? A log, right? It's a log. The other one had a number, so you'd have to move logs to one side, number to the other, okay? But when they're all logs, you can go log. So we could go, so it's going to be x over 15 equals 0.2 multiplied by 15. x equals 3, and we check it, it works because you can put it beside and it's positive. Now I want to go back to one question back here. You can just watch me. Now, because that's a 1, I could actually, and they do this sometimes, I could actually make that be a log, okay? So I can make it be like I did the other one. So I have log base 9 of 3x equals log base 9 of what? 9 of 9, right? Because log base 9 of 9 is 1. And I have to make it be log base 9 in order for this to work. So I could go 3x equals 9, divide by 3, x equals 3. Sometimes it's easier to do it this way because it's a 1. 1s are really easy. Sometimes it's like 4.6. Well, I don't know what log that's going to make to give you 4.6. Okay, so in some instances it's easier. In some instances it's just easier to do this. Okay, but up to you. And I want you to see both because what if they did, here's a step question, where did he make a mistake? You're like, well, he didn't do it this way, but he actually did it correctly, but you didn't realize he could do this, right? Okay. Try example 2. Okay, so we're going to get log base 3. Oh. Of x times x minus 1 equals log base 3 of 6. So you get log base 3 of x squared minus x equals log base 3 of 6. And now because we have log base 3 on both sides, we can just set what's beside them equal to each other. So x squared minus x equals 6. So x squared minus x minus 6 equals 0. And we get x minus 3, x plus 2 equals 0, x equals 3, and negative 2. We need to check them. So again, 3 beside here, 3 minus 1 is 2, so that one's good. Negative 2, nope. So how do they get around making you do this without y1, y2? They ask you for the extraneous root. Because then you can't, y1, y2 will never show you the remnants of the root that doesn't exist because it doesn't exist. So yeah. Example 3, what's the catch with example 3? You need to move the 2 up as the exponent. You're right. Because we can't say that log equals a log when it has a number in front of it, right? So we'll have log x equals log 27 times 3, which is 81. Wow, x squared, sorry. X squared equals 81 then. Square root, when you take the square root, you have to remember to take the 2 roots from it, plus or minus. So x equals plus or minus 9. And the negative 9 doesn't work. Then flip over. I think there's 2 questions. You guys can try them. And then we're going to do the 2-word problem. These 2. So you'll have log x squared divided by x plus 3 equals 3. This is the base 10. We could have changed it to this, right? So it's going to be 10 to the 3 equals x squared over x plus 3. I just dropped the base. It's 27, just like I said right here, but then wrote 10. because I really wanted to. I'm not quite sure why. We're going to keep going. 27 equals x squared over x plus 3. 27 times x plus 3 equals x squared. 27x plus, what's that? 27 times 3, 81. Minus x squared equals 0. Now, I don't like factoring with a negative x squared. That does not make me happy to try and factor it that way. I'm not even sure if you can factor it, but I'm going to move it all to the x squared side. So you can move this entire equation to the other side, and it just changes all the signs, right? And then you have a positive x squared if you want. I like dealing with the positive x squared for factoring or quadratic formula. Is there anything that multiplies to negative 81 and adds to 27? Did anyone find anything that factors? No? So x equals negative a negative b, so 27, plus or minus the square root of negative 27 squared minus 4 times a times c all over 2 times a. Calculator. Oh, hint, it doesn't factor. It says 2 decimal places. You get 27 plus square root of 1,053 divided by 2. So one of your answers is 29.72. And the other answer is 27 minus the square root. Oops. Of 1,053 divided by 2, which is negative 2.72. If I fill negative 2.72, it doesn't work. So the only answer is this one. Sorry. And then this one I'm going to do down here. Log base 4 of x plus 1 over 2x minus 3 equals log base 4 of 8. So you get x plus 1 over 2x minus 3 equals 8. X plus 1 equals 8 times 2x minus 3. X plus 1 equals 16x minus 24. This one doesn't have a squared, so life is so much better. Subtract the x. 1 equals 15x minus 24. Add the 24. $15x equals 25. Divide by 15. X equals 5 over 3. Which works when you plug it in. Stays positive. So now you'll be able to do the other questions on there as well. These ones that I didn't assign. Now we're going to do 2 word problems. We're going to do a decibels word problem, and we're going to do an earthquake magnitude word problem. We're given magnitude questions and we're given decibel questions often. And often they'll give you some weird wonky formula. I always, if it's magnitude, like an earthquake question or it's a decibel question, I always use the same formula myself, memorize it. Because what they'll give you is an equation that sometimes takes a few log rules to get you to the equation that we need. So I just memorize the equation. The equation that we often use for magnitude is I equals 10 to the m1 minus m2. Now there's a thing here where they go I1 over I2. Okay? I don't do the I1 intensity over intensity 2 because then you have to remember which one's 1 and which one's 2. What I do is I say if I is little, if the intensity of the earthquake is little, so a quarter is intense, half is intense, a third is intense, so between 0 and 1. So if my intensity is between 0 and 1, M1 is the small earthquake, small magnitude. If it's a big earthquake, so if the intensity is twice as intense, 100 times as intense, 50 times as intense, so big intensity, M1 is the larger magnitude. Ooh, that's supposed to be a 1. If I is greater than I. And the catch is, if they tell you the smaller magnitude's 5.3 and you put it in the wrong spot, you'll get like a magnitude less than that. And you'll be like, wait a second, this is supposed to be the smallest one. My magnitude is lower. I put it in the wrong spot. Try again. Okay? So even if you do put it in the wrong spot, you'll know you're right or wrong based on whether it's bigger or smaller of what it's supposed to be, right? So if you were given the larger earthquake and it's 6.7 and then you get the smaller earthquake has a magnitude of 7.8, something is wrong. The smaller earthquake's supposed to be smaller, okay? Then you put it in the wrong M. That's it. Put it in the right M, get the right answer, move on. Okay? So these ones are nice in the fact that they make sense or they don't. And you can adapt from there. Okay. So the intensity of two earthquakes as measured by the Richter scale can be compared with this formula, where M1 is magnitude 1 earthquake given on the Richter scale, and M2 is the magnitude of the other earthquake. I always just use the one above. So use the formula to show that the earthquake of magnitude 9 is 10 times as intense as the one of 8. So this is larger. This is smaller. This is my intensity. Now, larger and smaller is great, but larger and smaller changes depending on what kind of intensity I given. Like M1, M2 changes, sorry, not the smaller and larger. So my intensity is 10 times as intense, right? So my intensity is greater than 1, correct? So then M1 is what? Large intensity, M1 is large. Small intensity, M1 is small. And you might say, well, 2 times as intense isn't that big of a deal. If you're in an earthquake, 2 times as intense is a big deal. I would rather be in the one that's not 2 times as intense, to be completely honest. Earthquakes are crazy, right? So 2 times is a big deal. You don't want to be in that one. So don't say 2 isn't very big. It is an intensity sake, okay? So we have a large intensity. It's 10. So that means that my large earthquake is going to come first. So 9.0 minus 8.0. This is 10 to the what? 1. So then we get 10 to the 1 equals 10 to the 1. And we proved it works. So magnitudes are on base 10. They go up by base 10s, right? 10 times the intensity. So magnitude 8 to magnitude 9. Earthquake is 10 times as intense. Okay? So this one says, how many times more intense? How many times more intense? So they're looking for a big intensity or a small intensity? Big. So if they're looking for a big intensity, I'm going to put the big earthquake first. Which one's bigger? 8.1 minus 6.9. How do you know you messed up? If you put it in, you get a small intensity. Flop them, try again. Okay? So I equals 10 to the 8.1 minus 6.9, which is? And what's 10 to the 1.2? You could leave it at that, or we can look at a decimal, 15.8. They'll often leave it in this form, but they might change it too. So 15.8 times more intense. Does that make sense? We're going from 6.9 to 8.1. 7 to 8 would be 10 times as intense, right? When you go from one full magnitude more to the other. So if I went from 6.9 to 7.9, let's say, that would be 10 times as intense, correct? So 6.9 to 8.1, does 15 times more as intense make sense? Yes. So 6.9 to 8.1, when you get 1,000 times as intense, should make not sense. Should like that word. I've just made not sense. So it shouldn't make sense, right? At all. So you should be able to walk away and be like, yeah, I'm right. Or you should be able to walk away and be like, ooh, I did that wrong, but I'm not sure why. At least for the very least. Okay? All right. We have a major earthquake of magnitude 7.5 is 375 times as intense as a minor one. So this is when it starts getting a little bit more complicated. People don't know if I gave the bigger or the smaller. So a major earthquake, and they said major, so this is nice of them. A major earthquake of 7.5 is 375 times as intense as a minor one. So which earthquake did I get? The bigger. And this is my intensity. So I'm going to get 375 equals 10 to the, which one comes first? 7.5, because it's a big intensity, big earthquake comes first. Now, I could do this two ways. I could go y1, y2, and find out where they can't cross, right? If you have the calculator where the exponent doesn't pop up, you'd have to put this in brackets, okay? Or we could change it to a log, because we can always change it to a log whenever we have one exponent. I know this exponent is a large one exponent, but it's one exponent nonetheless. So we can change it to a log, right? Remember, we change from log to exponential when we don't know the variable beside or the base. We change from exponential to log when we have one base with an exponent. If we have two bases with an exponent, we no longer can change it to a log, and we have to log both sides. We agree? Could we go ahead and just log both sides anyways? Yes, logging both sides always works, just like the quadratic formula always works. However, factoring is easier, correct? So most people will change this to a log if they can. Changing it to a log doesn't always work, but it's easier, just like factoring is easier. So we always test it out first, even though it doesn't always work. Logging both sides would always work, but it takes more work because then we'd have to take this in front and distribute it and do a whole bunch more work. Okay? So when you have one base, you can change it to log. So log base 10 of 375 equals 7.5 minus M2. And then because I think you guys can handle this, I'm going to add the M2 over and subtract this over here. So I'm going to add the M2 to the left side, equals 7.5, and then I'm going to subtract this log over, so minus log of 375. And I can drop the base 10 off because log is base 10. If not, you can subtract the 7.5 over and then divide by -1. It'll get you the same answer, right? Should this be smaller or bigger? So we get 4.9, which is what's in the bracket. Okay, how many times more intense was the 1960 earthquake in Chile than the 2005 earthquake? So they want to know how many more times more intense. So they want a large intensity. So the large earthquake has to come first. So 9.5 minus 7.8. So it's 50 times. Okay, then we're going to go to the decibel one. We're going to go past the pH one. Oh, is the decibel one not on here? Okay, add. Okay. The catch with decibels, I'm going to see if I can find a textbook one of it, because I've seen come up on the diploma. Okay, this is the question we're going to look at. So it says Sound intensity, B in decibels, is defined by bells, blah, blah, blah. So if they give it to you that way, they're giving you actually the spot to put decibels. But the formula that we always use is the I equals 10 to the bells minus bells. So the catch is that they give it to you in decibels, but because it's base 10, we actually use bells, not decibels. So if it's 85 decibels, we're going to use 8.5 bells. We have to move the decimal over because this formula only works with bells, not decibels. Okay, so we're going to look here. A fire truck siren has a decibel level. So this is the fire truck. I could have drawn one, but that would take me years. So the fire truck is 118 decibels, and it probably wouldn't look like a fire truck. So that's 11.8 bells. Okay. City traffic has a decibel level of 85. So that's 8.5 bells. Because it's deci, right? We don't want deci, we want bells. Remember that decibels or decimeters or whatever is one step away from meters, right? So decibels is one step away from bells. That's why we're moving it one back. Okay. How many times as loud as city traffic is the fire truck siren? So which one are they making us find? Bigger intensity or smaller? How many times as loud as city traffic is the fire truck siren? Larger or smaller? Larger. So we're going to do I equals 10 to the larger intensity means larger earthquake comes, or larger decibel comes first. So 11.8 minus 8.5. Wow. Okay. This is funny. The sound of Ellie's farm tractor. Ellie's farm tractor is 63 times as intense. Tractors are crazy for hearing. Is 63 times as intense as the level of a car. The car is 80 decibels. What's the decibel level of the tractor? So the tractor is 63 times the car, which is 80 decibels. So what is the decibel level of the farm tractor? Don't have to ask you questions. So remember, you're going to have to convert to bells to use it, and then you're going to have to convert back to decibels to give me an answer. It is. No idea what you're talking about. It's all those decibels. How'd you not see them? They were decibels. There's decimels. Oh, too funny. No, I totally screwed that up. But yes, good job. Okay. What's 8 plus log 63? Is it 9, I think? 9.8? bells. So that's 98. Now, in your textbook, you should be able to do all of the word problems at the end of each section in logs. Okay? So I would go through and work in each of the sections of logs and try and do the word problems. Because in there, there's a lot of different word problems that are not like ones you've seen before, right? They give you a formula, you have to plug it in, you have to solve. And like I've said to you before, there will be ones like that on the test, right? There might not be, but there's a real high chance that there is because there's often more than not a log equation I've never seen before, right? And that's everything, so make sure you have your